Hello everyone, welcome back to the bonus lecture of this IoT course. Last session I have discussed what is green IoT, need of green IoT, then different principles of green IoT, sensor cloud and few research direction in green IoT. Today I will discuss a new topic, that is social IoT. As you know, in pre-internet era, human to human communication is done by fixed and mobile telephony and SMS. After that, Internet of content came, where www was introduced, and under www we had email, entertainment, etc. etc. After that, Internet of service came, where Web 2.0 was introduced. Under this we had e-productivity. After that, Internet of people came, where social network of human was introduced, like Facebook, like Twitter, like Instagram, etc. etc. After that, Internet of Things came, where machine to machine communication was introduced. By this, we can track, we can monitor devices, or one machine or smart device can communicate or interchange data. After that, social network of objects came, that is social IoT, where one object can communicate with other object without the intervention of human, and that is called objects social network. You can say this is social Internet of Things. Guys, this is the evolution of social IoT. That means if you want to get a service which is not in your device, or you can say in your mobile or laptop, whatever, you can get the service from other device, maybe from your friend device, if you have social objects network, that is social IoT. Agenda of this session: I'll start with background, then what is social IoT and why it is needed. Then I'll start with social IoT architecture, then IoT versus social IoT, few comparisons, use cases on social IoT, challenges in social IoT. Now I will tell you some facts. Total number of humans in the world around 7 billions, or you can say in current scenario it may be 7.8 billions. Expected number of objects, trillions. How to find the right object? That is the issue. Among humans, you can use social networks to find your friend or add your new friend. Why not the same for objects? Humans are connected to the internet through social networking like Facebook, Foursquare, LinkedIn, etc. etc. Internet of Things. 14 billions of connected devices by 2020. These connected devices become social. You can check this website http socialiot.org to know about the facts and figures. Guys, you can see the picture. Left side we have social network, right side we have Internet of Things, and now we can club these two and form a new thing that is called social Internet of Things. Guys, this is the picture. Social media monitoring in the Internet of Things era. So here you can see different smart devices, Wi-Fi, Twitter, Facebook. These are all social networks. How IoT is becoming social IoT. Now, what is social IoT? The social Internet of Things is defined as an IoT where things are capable of establishing social relationships with other objects autonomously with respect to humans. In this way, a social network of objects is created. I repeat once more, the social Internet of Things is defined as an IoT where things are capable of establishing social relationships with other objects autonomously with respect to humans. In this way, a social network of objects is created. That means an object can communicate with other object without the intervention of human. The objective is to get the service. If one service is not available with that device, then this device will get the service from other. Like our human network, if I want something like news or some information, you can get it from other person who is in Facebook or LinkedIn or Twitter, whatever be the case.
In social IoT, service discovery is most important because devices are getting services from other devices. Service discovery is a process of automatically finding appropriate services and their providers in IoT, taking into consideration requests, context, and QAs. In IoT, many heterogeneous objects offer different services, so it is challenging to locate desirable services due to the considerable diversity and large scale.
Why social IoT is needed? One of the most remarkable ideas behind the social IoT paradigm is that humans would not be involved in establishing relationships between the objects. Already I told you. The structure of the things social network is shaped in such a way that it is navigable in a logical manner. This would lead to an easier discovery of objects and services and would permit a similar type of scalability as the one seen in human social networks. Guys, it is absolutely scalable like human social network. Another benefit of the social IoT is that levels of trustworthiness can be established depending on whether or not objects are friends or not. This could increase or decrease the degree of interaction between them and would enable humans to measure the security levels of each object relationship. Guys, these are the needs of social IoT. Now I'll tell you different types of relationships. The first one is the parental object relationship. Second one is the co-location object relationship and co-work object relationship. Next one is the social object relationship, and last we have ownership object relationship. Now I will tell you each of this. Parental object relationship. It is typically established among homogeneous objects. Same generation devices made by the same manufacturer. It is established between objects that were produced in the same manufacturing batch, that is, same manufacturer, manufacturing period or model. Right? That means if you and your friend are using same brand, same model mobile phones. Next one is the co-location object relationship. It is established among heterogeneous or homogeneous objects that share the same environment. Smart home devices such as sensors and actuators have such short links because they are unlikely to cooperate towards a common goal. That means in your home, if you are using home automation, then your different devices or smart devices in your home like AC, refrigerator and all these things, they are actually co-location objects and they cooperate each other towards a common goal. Co-work object relationship. It is established between two or more devices whose functionalities are combined to accomplish a common goal. This type of relationship occurs between objects that either need to touch each other or to achieve that goal, or need to be in close proximity of one another. For example, emergency services. Next one is the ownership object relationship. Occur between heterogeneous objects, but the same user owns these objects. For example, mobile phones, gaming console, etc. That means you are owning one mobile phone, one laptop, one gaming console, etc. etc. Social object relationship. This relationship exists among the objects when their owners are different and come in contact with each occasionally or regularly. Smart objects belonging to friends, classmates, co-workers and companions could establish this type of relationship. Guys, this is the picture by which you can easily understand what is the social IoT, or you can say it's a very good picture to understand what is social IoT. So here we can see different devices, they are connected, okay, and one device can solve its problem by getting the service from different devices. You can see, guys, you can see these are the models for social network for humans and social network for things. Social network for humans having social graph, then we have service APIs, then relation model, then you have participation model, social presence, etc. etc. And at the middle we have profiling. But in social networks for things, you have relationships, management, service APIs, then you have trust, worthiness management, then you have service composition, then we have service discovery. At the middle we have ID management, profiling and owner control. Guys, you can see these are the two different models, one for social network for humans and one for social network for things. The components of the social internet of things, where we have object to object relationship, user object relationship and user user relationship. Guys, you can see we have physical objects over here. We have cameras, then we have notebook, we have printer and all these things. Then we have physical world, where we have smart park, where you have a smart car, we have smart building, etc., etc. And we have the social networks. So you can conclude from here, there are three types of relationship. One is called object object relationship, user object relationship and user user relationship. There exists a social relationship between the physical objects, digital space and user. This social relationship between human, things and things to things is social IoT. Physical world contains several real world objects that are embedded with sensing, actuating, processing and networking capabilities. These objects are fundamental constituents of an IoT application. Humans form communities among themselves based on several factors like common goals, interest, friendship, etc. While they are also bound to the physical object through relationships such as uses, ownership, etc. Physical objects also establish relationships among themselves based on characteristic features like interaction level, location, etc. Social IoT is intended to manage trillions of things when facing the problem of information and service discovery, and it is not meant for the sensing and networking in the IoT. As you can see, this is the social IoT architecture. So we have object, gateway and social IoT services. In object we have application layer, network layer, sensing layer. In gateway we have application layers, network layer and sensing layer. Already I have discussed all these things earlier. And in social IoT services we have network layer and the application layer. Application layer once again subdivided into three sub layers. One is base layer, next we have component sub layer and lastly we have interface sub layer. Guys, you can see in component sub layer we have profiling, then we have OC, OC stands for owner control, then we have SD, SD stands for service discovery, then we have TM, that is trust management, then we have ID management, that is identity management, then we have RM, RM stands for relationship management, then we have SC, SC stands for service composition. So this is the component sublayer. Now in interface sublayer we have applications, then you have human interfaces, then object interfaces and service APIs. And in base layer we have data and metadata, then you have ontologies and semantic engines. In network layer we have cellular networks, wireless LAN, internet, etc., etc. Now I will discuss some social IoT use cases. Now I will start with smart retailing. When a customer enters a supermart, the smartphone connects with the marter and customer's profile is created, which includes the preferred brand, the regularly bought items, etc. The smartphone interacts with the refrigerator storage placed at home. This instantly creates a list of items that are finished or need restoration, and the app is updated with a list of items to be bought. Guys, we can think about the automation. The customer only has to decide whether to buy the finished item or if they wish to buy a new item or wants to try a new brand. Social IoT enables the establishment of such type of object connectivity where no human intervention is required. Guys, already I told you. Next one is smart traffic management and surveillance system. The vehicles traveling to a particular route can interact with each other, provide updates on the number of vehicles moving towards a particular route. Guys, you can see the picture. If there is a fleet of vehicles moving towards a route and some of them are at a distance from the others, they can be directed to an alternate route. This can be done before the vehicle enters a congested route or on the prevent congesting a route based on the occupancy pattern from data collected by the sensors installed on the individual vehicles and the interaction among them. Surveillance can be done by the smart sensors or devices installed on the roadside that can alert the nearby police vehicle of any crime occurring or has occurred on any street. The police vehicle with smart devices will automatically access the equipment required based on the event that has occurred and can reach the crime scene in minimum possible time. Next one is smart healthcare. Very important. Healthcare is one of the domains that would greatly benefit from social IoT. A smart sensor on highways and roads can alert the smart ambulance of an accident. The smart ambulance can check the equipment required and reach the spot in minimum possible time. Smart medicine boxes can interact with sensors on the human body and can guide on doses, side effects, and provide reminders to consume it. Next one is smart shoe. Suppose a person is going outdoors for a walk. The smart shoe can sense the activities in the body from the sensors and reshape it based on the requirement of the body. It can also help track the movements of the person and can alert the sensors installed at the home in case of any emergency. It can also provide a detailed health report and send it to the designated healthcare center in case of abnormalities found. Last one is smart museum. As an user is at the entrance of a museum or any public place, he or she is prompted to install an app associated with that particular place. As the user installs, they are assigned a virtual assistant and based on the visiting pattern, interests, likes and dislikes captured from the social media guides the person through the place, informing about the specialties. They are navigated by the smart objects placed in the museum to reach, thus enhancing user experience. Now I will tell you difference between IoT and social IoT. In IoT, the inter-thing social dimension is not exploited. In social IoT, the inter-thing social dimension is fully exploited. In IoT, only the human to computer interaction model is exploited. But in social IoT, all the human to human, computer to computer and human to computer interaction models are allowed. In IoT, computers produce information or data and humans consume them. But in social IoT, both computers and humans are producers and consumers of information or data. In IoT, humans and computers interact through the client-server model. But in social IoT, humans and computers interact through the P2P model, peer-to-peer model. Some prerequisites of social IoT applications: personalization. Discovery system must necessarily calibrate the results to match the preferences of the user. Multi-attribute request. Discovery system should support requests containing more than one attribute, for example, location and time. Request range. Discovery system should support the requests that consist of upper and lower bound. Recommendation. Discovery system must provide recommendations of services if it fails to provide the required service. Already I told you the main objective is that to get the service from different devices which are not available in the device which is requesting for the service. Interactive and responsive interface. Discovery system should provide user-friendly interface and enhanced results such as object status, latest updates, generated events, etc. Next one is multicast feature and classified query results. Discovery system should provide multiple replies for a single request, and such results must be categorized into structured class based on request. Minimum latency. Waiting time should be at the lowest during different stages of discovery algorithm. Energy management. Discovery approaches must account for the energy consumption in the objects. This is very important. Interconnectivity. Discovery system must be automatically updated with IoT objects' current status. Accuracy. Such result must accurately match the query request and provide the most relevant results. Privacy. Such result must conceal the most sensitive information of the IoT objects. Security. Discovery approaches must account for the security level as per the users and objects specification. Trustworthy. List only the trustworthy results for the users. So now I'll come to challenges in social IoT. There are many challenges. I have jotted down few. First one is the scalability, then mobility, dynamicity, heterogeneity, interoperability, survivability, resiliency and adaptability. Scalability. Discovery system must manage the large number of objects connected to the social IoT, that is social Internet of Things. Mobility. Discovery system must handle the objects that changes its location more frequently. This is a very important challenge. Dynamicity. Discovery system should deal with constant joining and leaving the network that results with change in the network topology. Opportunistic existence. Discovery system should handle dynamic interaction status of the objects with the social IoT network. Heterogeneity. Discovery system should take into consideration a wide variety of objects, multiple communication protocols and variety of applications. Interoperability. Discovery system must function among heterogeneous data sources at different levels and platforms. Adaptability. Trust protocols designed for discovery system must adapt to the changing environmental conditions. Survivability. Trust management protocols designed for discovery system must sustain to malicious attacks. Resiliency. Discovery system should be resilient to attack and establish a secure communication channel. Standardization. Discovery system should be realized with widely accepted standard communication protocols. As these are the some challenges you have to overcome this for implementing social IoT network. That's it for today. Thank you very much.